past episodes, we showed you some of these big observatories that scientists use to study the universe. And as we have mentioned, there can be problems with interference from Earth's atmosphere. So the best way to eliminate that problem is to move the observatory outside the atmosphere of Earth, into space.
In this episode, we leave Earth and head to space to give you the rundown on some of the astronomy going on by satellites and planetary robots.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket.
We have been putting satellites into space since 1957, when the Soviet Union launched Sputnik. Since that time, satellites have become more and more sophisticated, and today we rely on them from everything from weather forecasting to television to communications.
The study of the universe also relies on satellites. They can see what ground-based observatories can't. Who isn't familiar with the incredible photos taken by the Hubble Space Telescope?
The Hubble Space Telescope is certainly the most famous of the orbiting telescopes. It is 13.3 meters, or 43.5 feet long, and its primary mirror is 2.4 meters across, which is almost 8 feet. It was named after Edwin Hubble, a great astronomer who studied the universe in the early part of the 20th century. The Hubble is mainly an optical telescope, in that it sees the visible spectrum, just like our eyes do. Hubble can also image near-infrared wavelengths using its near-infrared camera, and its imaging spectrograph can read the spectrum of deep space objects.
Hubble has made almost 1 million different observations since it went into space. It has helped determine the age of the universe at about 13.7 billion years old. It has studied supermassive black holes in other galaxies. It has studied planets being formed. It has studied dark energy and how the universe is expanding. And that is only a little bit of what it has done. Of course, it has also given us incredible photos of the universe.
The accomplishments of the Hubble Space Telescope are so vast, we will need another episode just for it. Currently, the James Webb Space Telescope is being built. The Webb telescope has a 6.5 meter mirror, which is about 150% bigger than the Hubble. With that, we should be able to peer back in time to near the beginning of the universe itself.
While Hubble looks at visible light, Chandra looks at X-rays. We cannot see X-rays with our eyes. They have a much shorter wavelength than visible light.
We, of course, have all seen X-rays of bones and teeth, but what you are actually seeing is the shadows of various densities of material that the X-rays pass through and record on film. Chandra has a special telescope that can measure and record the X-rays themselves. Variations in the X-rays produced by a space object are recorded. Also, just like at the doctor's office, anything in between the object and Chandra can be observed by how it affects the X-rays. Recently, Saturn's moon Titan passed in front of the Crab Nebula. Chandra was able to compare the X-rays from the Crab from when Titan was not there and when it was. Scientists were able to learn more about Titan's atmosphere.
Chandra studies things that give off X-rays, like black holes, pulsars, nebulas, and more. Chandra can even see an object up to the very last second before it is sucked into a black hole. Here is a photo taken by Chandra, a pulsar shooting out from a neutron star.
To avoid interference from belts of charged particles around Earth, Chandra has to be even further away than most telescopes. Chandra is in a strange orbit that takes it 1/3 of the way to the moon. A lot of what we have learned about the universe in X-rays has come from Chandra.
Looking at the wavelengths on the other side of the visible spectrum is Herschel. Herschel looks at the far, infrared, and longer wavelengths. These are the cold objects of the universe, the clouds of dust.
Herschel is run by the European Space Agency and ended its mission in 2013. But the images and data returned by Herschel will keep scientists busy for years to come. This fantastic photo was taken by Herschel and shows shockwave from the gases of Betelgeuse. Betelgeuse is a red supergiant and will one day become a giant supernova. It is currently shedding its outer layers of gas, and thanks to Herschel, we can watch it. The shockwave should collide with the interstellar matter, the straight line of gas on the left, in about 5,000 years.
Here are some other photos taken by Herschel as it studies remains of supernovas and other nebulas.
NASA's Infrared Space Telescope is the Spitzer Space Telescope. Like Herschel, Spitzer looks at the universe in the infrared spectrum.
Spitzer looks deep into the gases of nebula to watch how new baby stars are being born. It also looks at brown dwarfs, which are stars, but not really stars. They're between a gas planet like Jupiter and a star. They're huge, but never ignited to become a star. They are very cold compared to stars with a temperature around 1,000 degrees. They are too cold to see with visible light, but they show up in infrared.
Recently, Spitzer analyzed the cloud patterns on a brown dwarf.
Those clouds are huge, bigger than planets, and they are made up of hot grains of sand and liquid drops of iron.
Spitzer also analyzes planets in other solar systems. When a planet goes on the other side of its sun, Spitzer analyzes the infrared spectrum of the sun. When the planet comes around in view again, Spitzer analyzes it again, and now has a combined spectrum. Then the star's spectrum can be subtracted out, and what you have left is a spectrum of the planet itself. From that, scientists can determine the makeup of the planet.
This is a runaway star. Scientists think that once this star was part of a two-star system, the other star went nova and blew up, throwing this star out hurtling into space.
Spitzer took this infrared photo, and what you see here is the bow shock of dust as the star flies through space at 56,000 miles per hour. The star is called Zeta Ophiuchi.
We have seen space telescopes looking at visual light, X-rays, and infrared. The Fermi Space Telescope looks at gamma rays.
Here is what the Milky Way looks like in gamma ray. You can see the large amount of gamma rays coming from the center of the galaxy, as well as the high beams of gamma rays coming from some pulsars, such as Vela and the Crab.
Here's a close-up of gamma rays coming from a pulsar.
Gamma rays are also shot off from the black holes at the center of galaxies.
The universe is filled with gamma rays. Scientists, with the help of the Fermi Space Telescope, are just beginning to unlock what creates them and how.
By using all these space telescopes together, along with ground-based telescopes, scientists are putting together the puzzle of the universe.
There are more space telescopes and satellites than we could tell you about in one episode, like SOHO, that studies the sun. Kepler is looking for planets around other stars.
There are satellites studying Earth, too. Our oceans, the land, the poles, and the weather are all studied from space.
And don't forget the planet explorers.
That's right. Cassini is exploring Saturn, Messenger is at Mercury, and the intrepid rovers Opportunity and Curiosity are driving around on Mars.
New Horizons is on its way to Pluto.
Keep up with what the telescopes in space and around the world are finding by reading the Milky Way News on the Let's Explore Astronomy webpage. Until next time,
Happy stargazing! Check out our other episodes in Let's Explore Astronomy series at www.tedcookproductions.com/LEA.
You will find all kinds of cool astronomy topics there. Hey, give a shout out to our sponsors, without whom we would not be here. Visit their websites and partake of their services and products. A big thank you to the Yukon Department of Tourism and Culture and Westmark Hotels, Westmark Whitehorse.